Okay, so the giant stream in the Andromeda galaxy is a point of low energy due to the passage of a particle through the area. As a result, the stars are very cold and emit little energy. This is very similar to getting particles to approach absolute zero, and the lack of collisions amongst themselves is akin to superconductive behavior of electrons. Um, so there is this spot that is in the Andromeda galaxy, that there is this large flow or seeming flow or collection of like stars and things in the Andromeda galaxy, if I didn't say that, where the behavior of the stars in this location appear to have very low emissions and appear to all just kind of flow without any, collective reaction amongst themselves, right? So they're all in this collective flow without seeming interaction between each other, right? It looks like they're all moving, to my understanding, it looks like they're all moving in a direction. However, it doesn't look like they're moving in that direction because of forces, and it doesn't appear like they're applying forces on each other, and it doesn't appear like they're emitting a large amount of radiation. They appear to be either dimmer or lower energy compared to the stars around them in this space. And I think the reasoning for this could be because there is evidence towards there being a large collision in the past, or something along those lines, where two galaxies collided, right? Or like a galaxy collided with the Andromeda galaxy, and I think later on I talk about the leftover part of it that's still there. So in the Andromeda galaxy, there was this collision that took place. So the massive galaxy would have moved through all these stars and all this stuff that's here. Over time it would have moved through the galaxy to get closer to the center of the Andromeda galaxy, and as it kind of whizzed by, right, it would have just pulled everything in around it, right? And so there would have been this massive hole in space where there was just a whole lot of nothing compared to the rest of the galaxy, right? The rest of the Andromeda galaxy would have had a bunch of stars and all this stuff all around, but then you just have this void where the galaxy moved through and just kind of collected in and pulled in all of these rogue stars that are flying around, that were just minding their own business in the Andromeda galaxy. Now they got pulled into this other galaxy and got taken along for the ride. And so because of that, there's this big void there. But since there's a void there, it acts almost as if this massive, this region that is very cold and is akin to the behavior of magnetic fields, or like magnetic field lines, like the electrons will go into the magnet and then like continue through the, magnetic field. And that's how we get these magnetic waves generating from the electron flow, in theory. But also in superconductors, you have to cool them. Typically, you have to cool them down to very low temperatures, and then you get this electron flow through the superconductor that they don't really interact with anything. They just flow straight through without any resistance. And I think that we are observing something of that behavior on a much larger scale. And that's what I'm trying to say with this talk on this giant stream in the Andromeda galaxy. There are also rings in the Andromeda galaxy that point to collisions taking place in the past. And this is potentially proof of atomic bonding. They would also make sense for electron orbital or cloud distributions. So having having this inner ring, outer ring kind of thing seems awfully similar to having, inner and outer orbitals for electrons. So I thought that that was kind of interesting. And there's a large collection of electrons in certain spots, and that's because that is where there's a high density of, stars. So high density of stars are kind of like electrons potentially. That's why you're most likely to find them there, because that's where there's just a ton of them that have been congregated at. That's what I was trying to say with that. Whether or not that's the case, I don't know, but I wanted to propose it. And they think that these rings formed because of during the collision. Basically, what would have happened during this collision, it wouldn't have been like, oh no, here comes the other galaxy, and then they just hit head on, right? What would have happened, and what probably did happen, considering that the galaxy is still technically separate. It's within the Andromeda galaxy, but it is not completely merged with the Andromeda galaxy, I think is maybe the better way to say it. So what would have happened is like, just like a comet flying around the sun, it comes in really close, it goes, and then boom, and then it flies off, and it goes off again, and then eventually it'll come back, right? So the other galaxy would have come in and goes, just missed them. But as it does this, right, it's collecting, it's pulling, it's just kind of gathering all the stars, right, around it, and these stars are slowly being bled off as like a wake as it goes through the galaxy, through the Andromeda galaxy. So you get a concentration on the sides of where this orbital path would have been, and then like a more of like almost a void or a lower concentration of stars and mass where the other galaxy flowed through. And then even if the galaxy stops moving around that area, now that void is kind of locked in place, and so maybe it'll slowly start to fill in, but you're still going to have areas where there's less and higher, because as it's filling in here, there's also more collecting and congregating in these points that have already been built up, and so you end up with these rings that kind of just stay there and are a remnant of what happened in the past. And so the collision and following bonding lead to a massive release of energy, and the remnant galaxy that is now Andromeda's companion, M32. So there is this remnant galaxy that is considered Andromeda's companion. It's called M32, according to what I wrote here. And so what I'm saying is that initially, M32 probably was its own galaxy. It was probably had a lot more energy than it does. But when it came in, it came in, and I would consider this as it has now bonded to the Andromeda galaxy. And so now there is this bond that formed, and when this bond formed, the excess energy of this remnant M32 galaxy was released. And so this would have resulted in the Andromeda galaxy setting off large plumes of energy, probably something similar to the radio bubbles that we see in our galaxy. In the Milky Way galaxy, we notice these radio plumes. There probably would have been massive ejections of energy from the Andromeda galaxy as, this congregation of mass them coming together would have resulted in as they went to bond, it would have, one, dumped off some of its mass that it had accumulated, and two, would have helped kind of push some mass into the center of the galaxy and congregate it and increase the amount of energy that it is releasing. And so what I think happened is the reason why M32 is considered a remnant galaxy now is because it was in a high energy state, but when it bonded, it reached a stability point, and now it is in a bonded state with the Andromeda galaxy, but no longer has that excess energy because it kind of dished it out when it bonded. It had to lose that energy when it created the bond. And so this could also be a big reason why we see these rings and stuff, as well as, when energy was released out, probably would have resulted in some severe gravity waves. And these gravity waves would have then had an effect on the surrounding stars and everything else that's in the galaxy around them. That could have also resulted in the forming of some rings, potentially. I don't know. The things that I think is most interesting about this is the seeming superconductive behavior of the stars in the Great Stream or whatever, and also the seeming bonding of two galaxies into one system. They are still technically like two separate things, but they are all within the Andromeda galaxy now. And so it's almost as if, we just witnessed, a molecular bonding taking place, which I find interesting and I think is pretty cool. So, yeah. Peace out.